Okay. Don't have to write this down. But we've been doing inequalities. We've started to solve inequalities that look like this. How to solve it? Subtract 4 from both sides. And our answer is x less than or equal to 3, right? Okay. So if I gave you something like this, what would it be? Plus 2. So x greater than, careful, negative 5. Okay, and then we graph them on a number line. Okay, so just like solving an equation, except the symbols, instead of an equal sign, we've got an inequality sign. One thing that we haven't done yet is what happens if there's some multiplication or division involved. So like if I said this, 2x minus 3 greater than or equal to 5. What would you do? After the crime?
Add 3 to each side.
Add 3 to both sides. And you get 2x is greater than or equal to
8.
8. And then
Divided by 2.
Divide by 2 to get the x by itself.
And then x is
Greater than or equal to 4. What if I said this? What would you do?
times 3.
Times both sides by 3. Because times 3 and divide 3 cancel each other out to 1.
And we're going to 2 times 3.
And you get x less than or equal to negative 6. So it seems like multiplying and dividing is pretty straightforward.
Yes.
Same with addition and subtraction,
Yeah.
except for one thing. Now I'll go back to the beginning. Okay. What if I gave you this? If I said, okay, 6 less than 8. Is that true?
Yeah.
Yeah. Yeah, it's true. Okay. If I times both sides by 2, I get 12 less than 16.
That's true.
That's still true. But what if I took the original and multiplied by negative 2? I get negative 12 less than negative 16.
That's false.
That's false. So notice what happens. We have a problem when we multiply both sides by a negative. Okay? It's false, but true if I reverse the inequality. So if I multiply by negative 2, I should change it to negative 12, reverse this to greater than negative 16. So that's one thing you have to be careful of. Whenever you solve an inequality and you multiply by a negative number, you have to reverse the inequality. Same thing with dividing by a negative number. Again, if I gave you this, 6 less than 8, we know that this is true. Okay, if I divide both sides by 2, I get 3 less than 4, which is also true. But if I took the originals and divided by -2, I get -3 less than -4, which is false. But true if I reverse this. Okay? So when you solve inequalities, you solve them the same way you do equations. Except that one thing you got to watch out for. On your way to solving, if you ever multiply or divide by a negative number, you got to reverse the inequality. Okay? So let's just look at some practice. We're not going to graph every one of these. We'll graph 1 or 2. How would I get x by itself here?
Or
Add 5? Isn't this -5 times s? I have to divide by -5, divide by -5 to get s on the left side, -5. And what happens to the inequality? Because I divided by a negative. Reverse it.
But if you divide by a positive, you reverse it?
Exactly. The only time you reverse it is if you divide by a negative or you multiply by a negative. So in B, what do I do to get A by itself?
Let's divide it by 7.
Divide by 7, which means I have to divide the right side by 7. Did I divide by a negative?
No.
No. So I don't reverse. Leave it. And -21 divided 7 is -3. It's okay if it's negative on that side. I didn't divide by a negative. How would you graph this one on a number line? Let's just do this one. Two notches, yeah.
The 3 on the line.
The -3 here, which means 0 goes here.
All those circle.
All those circle out the -3.
And then go and that one.
Follow the arrowhead. Yeah. Okay. In C, how would I get y by itself?
To times by -4
Times by -4 times by -4. So times -4 and divide -4 cancel each other out. -3 times -4 is 12. And I have to reverse the inequality because I multiply by negative. Okay? And the last one,
times 3.
times both sides by 3. So times 3, divide 3, cancel each other out. I'm left with k.
Inequality.
Keep this the same.
And then maybe -6.
Perfect. Yep. Okay. So let's look at a few more examples. Again, we'll graph maybe one of these. I think you guys are pretty good at that, so we're not going to do every one in the interest of saving a little time. Okay, how would you solve this? Add 1, and I get 7x greater than or equal to 7. Divide both sides by 7, and I get x. Yeah, no reversing taking place. I didn't multiply or divide by a negative. How about this one? Got 2 from both sides. And I get negative 3x less than 6. Whoops, negative 3x.
And then divide by negative 3.
Divide by negative 3.
And then
X.
greater than.
Right, we reverse. Gotta reverse. Greater than negative 2. Yeah, so we gotta reverse.
Bring me X over.
What's that?
Do you bring me X over first for the next one?
For the next one? Yes, we do. Yeah, because remember, when we've got variables on both sides, we got to bring them together. So I'm going to swing this over by subtracting x, and it looks like 2x
No less than 2.
right?
Negative 5.
Okay.
And then add 5.
On both sides.
2x is greater than less than or equal to 1, 0.
0. Negative 5 plus 5 is 0.
Then divide by 2.
And x is
Less than or equal to 0.
0. Good. How would that look in a number line?
2 notches.
Do I need 2 notches this time?
No, or just 1.
Yeah, just because it's 0, right? So I could put it in the middle of the column. 0,
A building circle.
filled in circle,
And to the left.
to the left. Good. Excellent. And the last one here. What would you do first?
In reference, or yeah, in the reference.
Yeah. Figure these up by multiplying everything inside by 2. So I get 2 times 2x is 4x, plus 2 times 1 is 2. Now it looks very similar to the last one where we had variables on both sides. Bring this over here, this time by adding it. So I get 7x plus 2 greater than 9. Subtract 2. Subtract 2. I get 7x greater than 7. Divide 7. Divide 7. Greater than or equal to 1. And no reversing needed to take place. It's not an equation we're doing. It's an inequality. Oh, that was my mistake. It should have been just greater than, because the original one was greater than. Yeah, let's do this one. It's good practice. What you do first?
The brackets.
Yeah.
Balancing everything like.
So I can do the parentheses on both sides. So what does it look like?
3x plus 6. 3 equals 5. Subtract.
Excellent.
Then you're going to bring over the x by subtracting. Add part of it. Then there minus 6.
Both sides. 8x greater than or equal to -1. Divide both sides by 8. And I get x greater than or equal to
1.
Don't overthink it.
-8. -1. 1.
I can't divide this cleanly, right?
You don't just.
So it's -1/8. Don't overthink. Can't divide cleanly, leave it as a fraction. Don't try and change the laws of mathematics. Where would I put 0? Where would I put -1/8?
-1/8 on the left.
-1/8 on the left, which means 0 goes here.
Do you have to do 2
Yes. Really? Is it going to kill you? Really? Really? Wow. Wow. Really?
Oh, wait.
Really?
And then.
Wow. Really? Really? Wow. Wow.
To the right.
Wow. Really?
Really?
Wow.
To the right.
Really?
Yes.
Wow. Like wow.
Yeah.
Okay. Oh,
I think.
that.
Yeah, I thought.
Actually, yeah, let's go back to that one. That's actually we have to go back to later. Let's finish this before we do a problem. Okay, this is throwing together everything you know.
Great.
Try and be a little bit more positive there, sunshine. So, I've got something that I need to get rid of right away. What are they? The fractions. We don't like fractions. We want to get rid of them. How do we get rid of them? We multiply everything by the lowest common denominator. So everything gets multiplied by 4. Excellent. Because it's hard? Is that what you just said? This is hard? You can do it. You can do it. And remember how we do these. Times 4, divide 4, cancel to 1 and 1. And 1 times 3x is 3x. Fraction gone. Life is good. Nothing to cancel here. 4 times 5.
20.
Something to cancel here. 4 divided 2 becomes 2. And it's always 1 on the bottom. It's always 1. So I'm left with 2 times 1.
2.
No canceling here. This is just 4x.
We bring the 4x over and subtract 4x.
Correct. So I get negative x plus 20 less than 2.
And then we have to subtract
20, 20, and I get negative x less than negative 18. I'm very close to done, but I have to solve for x, not negative x.
Okay, you have to do the thingy where you go like line and it goes down and up. What's it called? You know, like it goes like this. Division?
Square root? No. Actually, we don't do square root here. We will be doing square roots, but not just yet. Think of it like this. That's the same, right? How do I get rid of times negative 1?
Divide. Divide by.
So I get x
X, and then you have to flip the thing, so right.
So that now, so add an exclamation mark, 18. Okay? You can do ones like that. You've got a very good handle on these. Okay? Now let's just look at the problem 3, or pattern about 3. A super slide. Sure, thank you. Charges $1.25 to rent. A mat. Sorry, a super slide charges $1.25 to rent a mat and 75 cents a ride. However, it has $10.25. How many rides can you go on? Okay, we want to do an inequality. What's the unknown?
How many rides?
Okay, so rides, we'll call it X. So now I'm going to make an inequality. Notice it says modeled with an inequality. Well, how would we write this? Like a super slide charges $1.25 to rent and 75 cents for every ride. 0.75x, and he has to pay $1.25. Remember, it's an inequality, not equals. Well, how much money does he have? $10.25. Less than or equal to. Right? Because he doesn't have to spend the $10.25. He can spend less than that, but he can't spend more. So let's solve this. So this is B, we're actually starting to solve. And we get 0.75x is less than or equal to $9, or 9. Then we divide 0.75. This is where obviously we want to use a calculator to help us. Should work out to 12, I think. Yes? No? Maybe I'm wrong.
Wait, I'm not. Cancel, you're right.
12? So how would we answer this question?
You can go on some direction.
Almost. You need two more words. He can go on 12 rides
Or less.
or less.
Because he doesn't have to.
Because he does, yeah. So He can go on 11, 10, 9, 8, 7, etc. Okay? You just can't go on more than 12. Good. Okay.